Next, I would like to move into a conversation on radicals, which, as we hopefully will remember shortly, also relate to exponents. Now, take, for example, this exponent, 16 to the 1/4 power, which actually represents a radical that is a fourth root of 16. As we want you to remember, the denominator always is the root, and the numerator is actually always the power. Of course, this one has a power of 1, so it's really not needed, doesn't need to be shown. But now we find ourselves trying to find the fourth root of 16, which of course are four numbers that multiply to be 16. And oh, by the way, they have to be the same four numbers. So of course that would be 2. So what if we wanted to do 64 to the 2/3 power? Well, same thing. This can be thought of as a root and a power. And again, the denominator is always the root. The numerator is always the power. Now, I don't know about you, but I don't want to do 64 squared, especially if I'm trying to do that without a calculator. So it may be better to think to ourselves, well, what's the third root of 64? Let's find that value first. And that does indeed come out to be 4, because 4 times 4 times 4 is 64. Now I can do 4 squared, and we end up with 16. So remember, the general property here is that a to the m over n is the same as the nth root of a to the m. On the next slide, I'm going to have 3 problems for you to try on your own, and why don't you do them without a calculator? Okay, coming up next, we're going to solve all 3 of these, so make sure you push pause if you haven't found each of these 3 answers. If we do the root of 9, we can easily come up with the number 3, and then if we cube the number 3, well, of course, we end up with 27. Now, here we have a negative exponent. I tend to like to understand that the negative exponent is really just going to cause this answer to be a flipped base. I can rewrite it right now if I want, or I can just go to business trying to find the fourth root of 16, because either way, I have to be able to have that number 2. But again, really my final answer just ends up in the denominator. It ends up looking like a 1 over. It ends up being a flipped 8, so we have 1 over 8. Now with this last problem, we don't have a negative exponent, so don't try to flip something just because we have a negative number. Instead, you want to try to find the fourth root of negative 16. Now, the fourth root of negative 16 does not exist. Since that's an even root, I'm unable to get 4 numbers that multiply to be negative 16. But the other part behind this problem is to think about what if the problem had read negative 16 to the 3/4 without the parentheses. Well, a student wants to understand here that the exponent always applies to the immediate base. Here, the immediate base would have to be just 16. In other words, we would have to assume that we're doing the exponent to 16, and then we're going to end up with a negative answer when this is all over. Now, this can be done if you want to do this problem. We're going to end up with a 2 to the 3rd power, which comes out to be 8. But again, this negative sign really is just saying that my final answer is going to be the opposite of this value of 8. Okay, so be careful about where and how the negative sign is being used. What if we kind of mix a little bit of radicals with exponents? Well, there are different ways to go about this problem, but just for the sake of the first time through here, I do encourage students to think about that square root as an exponent, a rational exponent of 1/2. I certainly can do that. And what that does, it allows me to realize that when you bring in this basically this root or this rational exponent, that it's going to end up dividing. It's going to end up dividing by the into the exponents that were already present. So we take 3 and we divide it by that 2. We take x squared, and of course we divide it by that 2, which is certainly going to give us an exponent of 1. Now, If you can, you should. If you can do 25 to the 3/2 power, you should do it. Because there is a root of 25. It, of course, is the number 5. And once you get the number 5, you can raise it to this third power and end up with 125. Of course, x to the 2 over 2 is the same as x to the 1. So can we change a root, in this case a square root, into a rational exponent? Sure. But really what ends up happening is that this root ends up just becoming the divider of both of your exponents. Here, try a problem on your own. Okay, now maybe you decided just to kind of use my little shortcut, and you're going to ultimately just make 3 become the divider or the denominator of each of these existing exponents. That's totally fine. If I choose to go that route, I'll get 64 to the 1/6. I'll get x to the 6 over 3, which we can just, well, I'll go ahead and show that, and then we get y to the 1/3. Now, can we simplify any of these? I believe we can. Are there 6 numbers that multiply to be 64? It's nice to know that that is the number 2. Of course, we have x squared with some simplifying. Now, how do we want to write the final answer? Well, it depends on how the directions are read, but if the directions say to write the final answer with a radical, then I think I would be forced to put this one back to the cube root of y. So I would get 2x squared, the cube root of y, writing my final answer in radical form. Now, if you would like, you can try this problem on your own, or if you want to wait, I will explain it as this problem, the cube root of 24x to the 8, has a little discussion on taking out even roots that are inside of this third root. Remember doing this in Algebra 2, you want to try to split 24 into 2 numbers, but one of them that evenly roots with 3. So our brain should be thinking of the number 8, but there's also a 3 required to equal 24. When I do that, that allows me to take the even root out. That 8 is going to come out as a 2. It's going to leave behind this 3 that was not able to come to the outside of that root. Now, that's how you do it with actual numbers. When you have a variable, the thinking is a little different. You want to think, what's the highest amount of x that's inside of x to the 8 that roots evenly? What's the highest amount of x inside of x to the 8 would be x to the 6. Now, that requires us to also think of an x squared as part of that, but it's this x6 that's able to come out. Remember, when it comes out, it divides by this 3. And so that's why we end up with an x squared. So again, we divide the 6 by that 3. It also leaves behind an x squared. So this is known as simplifying a radical purely by taking out, again, those even roots. Now, as I hope you can tell, we're really mixing and matching exponents and radicals, and we're just creating problems that continue to be able to be simplified. And let me encourage you to simplify these without a calculator. That is the idea. Here we have a problem that involves some exponents. Again, they are in a fraction. Fraction means subtraction. So if you subtract the exponents, top minus bottom is going to end up giving us, with a common denominator already present, is going to end up giving us negative 5 over 5, which is negative 1. Now, a mistake that I see with students in a problem like this is that they will tell me that the final answer is negative 1. But what you're really trying to say is that the exponent's negative 1. So, of course, since you're not going to cancel these bases, you're going to end up with the base 2 to the negative 1 power. Now, I hope that you're not done yet, because we never want to leave an answer with a negative exponent. Really, 2 to the negative 1 is the same as a flipped problem, namely 1 over 2 to the positive 1. Of course, we don't need to show that, so our final answer is 1/2. You want to try one on your own? I encourage you to simplify 64 to the 2/3 times 64 to the 1/6, trying to use properties of exponents. Now I'm going to show the answer, so if you haven't found the answer yet, you might want to pause the video. The idea here is to try to get students to add them. You want to add these exponents. Now, of course, the task of adding these exponents requires a common denominator. We can pretty quickly change 2/3 by multiplying the denominator by 2 and the numerator by 2 to be 4, 6. So when I add these exponents, I can end up with 5, 6. Now, be careful, the final answer is not 5, 6. Rather, the exponent is 5, 6. Now you want to be thinking, do I have a sixth root of 64? Are there 6 numbers that multiply to be 64? Yes, there are. It's the number 2. And of course, we still have the power of 5. So 2 to the 5th with some multiplication and rules of exponents ends up being 32. Now, that definitely is 100% correct, and it's sort of what I wanted you to do. But I'm wondering, do you realize that you could have also just found 64 to the 2/3 power? In other words, there already is a third root of 64. It just so happens that that's the number 4. And of course, 4 squared is 16. So we can find that full answer to be 16. And then, as we've seen a couple times, the sixth root of 64 is already 2. And so we can find that answer to be 2. And we are multiplying these together. And lo and behold, 16 times 2 is also 32. So sometimes the problems can be done multiple ways, and sometimes they cannot. This example right here is to tempt you maybe to try to do this problem multiple ways, but ultimately there's really only one correct way. Let me remind you that the incorrect way would be to bring this exponent in. That is a math teacher's nightmare. I wake up at night saying, no, 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 and instead say, why don't you actually just do the parentheses? Didn't we learn that you can always do the parentheses before the exponents? Now, how do you do the parentheses? Well, how about 2 to the negative 2? That's the same as 1/4. And can't we do 1/4 plus 3? Well, sure we can. It's just going to come out to be 13/4. Now, you can do a little bit of common denominator thinking here. This is really 12/4. So end up with 13/4 to the second power. Oh, now I can square the numerator and denominator like one of the properties says. And so end up with 169/16. Now, notice how we got this answer without using a calculator, not a decimal, but quite frankly, just following the order of operations. So here's one last problem to try. Do you think you can simplify this correctly? And again, let's keep the calculator away. All right, we're going to go over the answer, so if you don't have it yet, you might want to pause the video. Of course, one last time, we are not going to bring in this exponent. That's not a property when you have a plus or minus sign, but we actually can do the parentheses. Now, to do the parentheses, we have to think a little bit about how to work out 2 to the negative 3. I hope that you think of that as 1 over 2 to the positive 3, which I think we're ready just to write that as 8. We're also going to have to add an 8th plus 2. That's going to require a common denominator, so the number 2 is really 16/8, which now gives us 17/8. Now, 17/8 is to the negative 2. I really don't want to bring in a negative exponent because then I'll just have 2 negative exponents. Instead, it would be appropriate to flip the base so that when you flip the base and have 8/17, now your exponent becomes a positive exponent, which we can freely square each of the numerator and denominator. 8 squared is 64. 17 squared is a little bit big, but with enough thinking, we end up with 289. So we have 64 over 289.